The SLM Slideshow Player software is intended to ease the display of images and image sequences on HOLOEYE Spatial Light Modulator devices. The image files may represent computer-generated holograms, phase maps, or amplitude distributions. There are two versions of the Slideshow Player available: the standard version and a core version. The standard version is fully featured, with a preview window and based on internal network transfer, enabling it to be used even in a remote PC scenario. The speed-optimized core version can only be used locally and is missing some features, like preview window, to lower the risk of increased latency or even frame drops when playing image sequences. In most cases, we recommend using the standard version. After starting the Slideshow Player software, go to Files menu and select New Slideshow. The files used in a slideshow must be stored in one single folder. Select the folder with your images or phase masks and select the images to be displayed. You can use Ctrl key plus A to select all images. Now click Open. At the left side, you find several options for playback speed, beam manipulation, data transformation, adjusting gray levels, image show options, and display mode. Most of these options can also be adjusted later. For now, use the Show option drop-down to select how your input should be displayed on the SLM. The most common options are Original Unscaled, if you use an input image in full resolution of the SLM, and Tile Data, if your phase masks are calculated as smaller tiles, for example, if generated in HOLOEYE Pattern Generator software. At the Display Mode drop-down, select if you want to display your input in amplitude mode for images, or in phase mode for phase maps or computer-generated holograms. Click Apply and Close. All images will be loaded into the memory. This process may take some time, depending on your PC's capabilities and on the folder size. You can then hit the play button to start the slideshow. You can change the Show option in the left drop-down and the playback speed in the right drop-down. For the speed option, you can use 3 different units: frames, milliseconds, or hertz. At the Beam Manipulations tab, you can overlay blazed gratings to shift your reconstruction in horizontal and vertical direction. Or a lens function to change focus settings, for instance, to operate at another working distance. At the Transform Data tab, you have options to resize the bitmap data. Note that interpolation effects may occur when using non-integer zoom factors. Shift the image along the X or Y axis on the SLM screen. This option is helpful for alignment in a complex optical setup. Flipping the image along the vertical or horizontal centerline. At the Gray Level tab, you can adjust the gray level, respectively phase levels, of the input images to optimize or fine-tune your results. Besides these basic functions, the Slideshow Player offers several advanced features. You can directly calculate computer-generated holograms from your input images. Click the CGH Calculation checkbox to activate it. Use the slider or the number field to adjust the image size relative to the diffraction unit cell. If the Allow Cropping checkbox is enabled, the input image can be zoomed in up to 5 times to adjust the image detail or to crop away black borders. If you now click Apply and Close, the CGHs are calculated and loaded into memory. This may require some time. The Optical Setup dialog stores parameters describing the optical system the SLM is integrated in. It stores information about the illumination wavelength, aberrations in the form of Zernike coefficients, mechanical deformations of the SLM, and chromatic shifts when using multiple illumination wavelengths. Optical setups can be stored in separate HEOS files, which can be shared between different slideshows or used in the HOLOEYE Pattern Generator and SLM Display SDK. Click the New button to generate an optical setup file. Now click Edit Setup. There are options for monochrome laser setups and for the use with RGB lasers for color sequential CGH reconstruction. For a monochrome laser, you can set the wavelengths of the laser which is used for correct handling of Zernike polynomials and wavefront corrections. At the Wavefront Compensation tab, you can activate the use of wavefront compensation files. These files are provided with the SLM and can be found on the included USB thumb drive. Click the Save button, followed by Apply and Close. The Wavefront Compensation overlay can now be toggled on and off in the player status bar. To overlay Zernike polynomials, you can either go back to the Edit Setup dialog in the slideshow settings or simply click Edit Optical Setup from the Files menu. At the Zernike Parameter tab, click on Enable Zernike Parameter to enable the adjustment of the Zernike polynomials. You can export the settings for use in the HOLOEYE Pattern Generator software or the HOLOEYE SLM Display SDK. You can also import the settings generated within one of these. You can now toggle the Zernike overlay on and off in the player status bar. For RGB lasers, you have to set the wavelength for red, green, and blue. Also, Zernike parameters have to be set for each color channel. Some HOLOEYE SLMs like Lido 3, Gaia 2.1, and Luna can be used for color sequential computer-generated holograms using the RGB color channels of an image and an RGB laser source. The Slideshow Player also offers the possibility to calculate RGB color CGHs from color input images. Applying color CGHs without the proper adjustment of wavelength and optical parameters results in inaccurate reproduction of the three color channels. Create a new optical setup file and click Edit Setup. Select the RGB laser checkbox and set the wavelengths for red, green, and blue of your laser source. Dependent on your optical setup, for example, if you use a magnifying lens, you may also adjust the chromatic angular scaling correction factors. Otherwise, the red, green, and blue channels won't fit in the reconstruction. With the correct wavelengths and optical parameters applied, the color channels of the reconstruction fit, and overlays of functions work without color shift.